Okay. I think I'm recording. Who knows? Okay. So synthetic division, which is fantastic. We've done synthetic division before. Algebra 2, pre-calc, all the things. So we're going to divide. Have we done long division, actually? Okay, so synthetic division is like the better piece of this. So we're using synthetic division because we're going to start solving polynomials, finding like the zeros of them, so we need to know how to synthetically divide to find other zeros. So that's our goal. So we should remember how we like typically divide things. So division algorithm, I could take some polynomial f of x and divide by g of x. So I want to say like g of x, I could have written d because that's my divisor. And then f of x is like my polynomial. Yeah. So what do I get out when I divide like anything? What is that called? Quotient. Yes. Good. So I get out my quotient. But do things typically divide evenly? No. What could I also get? Like if I have 3 divided by 5. I know 3 goes into 5 once, and I like subtract around and get 2. What does 2 represent? The remainder. So I can write the remainder as a fraction. So it's over what we were actually dividing by. Okay, so this is one way to write polynomials like as an equation basically. I could technically multiply all this by d of x. So this whole thing times d of x. So then I get f of x equals q of x times d of x plus r of x. So this is just another way of writing it. They'll ask you to express polynomials like this. Mainly because we want to rewrite polynomials f of x as a product. Most of the times we're going to try and hope for a remainder of 0. So that way we just have a product equal to my polynomial. So that way it's not like a fraction anymore, basically. So that's our goal. So if we're synthetically dividing, synthetic division only works if the divisor is linear. So I can make a note. Divisor has to be linear. Do we remember what linear actually represents? It forms a straight line. What kind of polynomial do we have in linear? So the first power, so it has to be like x minus 4 first power. I'm trying to decide how I want to say this. So synthetic division sets up like this if I have f of x divided by d of x. We have the constant of d of x right here in that little L-shaped box. Do you remember that? And then these are all the coefficients of d of f of x. So basically, we're just going to have a stream of numbers. It's going to look like my bonus problems with the little L thing. So you'll have numbers and then something in the L. So when you do it, you'll drop down the first term. And then you'll have a number, and then a number, and a number, until you get to basically the last number, which is the remainder. We'll do an example to actually let this make sense. But the goal is you're just adding and multiplying the entire time. So you'll multiply these numbers, and then you'll add vertically. That's my hot mess of notes right there. Okay. So I would like to set this up in a synthetic division, mainly because this piece is linear, so it's to the first power. Okay, so I would like to write the number into my L-shaped box, which is the constant, but it's always going to be the opposite operation. So my constant for my linear part is +2. The number that's going in the box is -2. So we change the sign basically because long division we subtract down. We want to add just to make it easier, so that's why I make it the opposite sign. And then what are the coefficients of my cubic polynomial here?
5,
Yep.
-6,
Okay, just list them all out. You have to hit every single term too. So if you're missing like the x, you have to put a 0 and replace the x value. So I have all my coefficients. I like to draw a line to separate my work. So first term always drops down. And then we have to multiply around. So -2 times 5 is -10. And I want to add vertically, so -6 plus -10. And you repeat the 5, so let me multiply again. -2 times -16. And then we're adding 4, and then multiply again. And then add. Okay. Now I always like to put like a line to separate because this is actually my remainder. Last number is always the remainder. Okay. So these are the numbers I get out when I like divide it, but I still need to write it as a polynomial. So if I divide a cubic by a linear, what kind of polynomial should I get out? I should have a quadratic. So basically, my first term 5 is 5x squared. And then my next number, -16, is the coefficient with x. And 4 is my constant. Then I also have to add into my answer my remainder, which is -10 divided by x plus 2. Yeah, my linear part. So that's my answer. And we could have gotten that by doing long division, but that's always a really long process. So
the long division where you have like x plus 2 and
yeah,
plus that, and then you go.
yeah, not too much fun. Which you'd have to use long division if this was a quadratic or cubic that we're dividing by. When it's linear, that's nice when we can use synthetic division. Okay, I just wanted to do another one because this one is more interesting because we're missing terms. So a number goes into this lovely L-shaped box. 1, changing the sign. And then the coefficients of x to the third minus 1.
Would be 1 for x.
1 for x to the third.
And 0, 0, 0.
Then yeah. So you have x to the third, x squared, x, and negative 1. Okay. So then do the same thing, dropping the 1 down. Then we start multiplying and adding. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -1 plus 1 is 0. So I write remainder is 0, so I don't have that fraction in my answer. But what's my polynomial? Call this one. X squared plus x plus 1. All my coefficients are 1 with a constant of 1. Okay. Last one. They'll ask you to write in a specific form. So basically they want you to use like division algorithm and write it in this form as the product with the sum of the remainder, if there is a remainder anyways. So doing the exact same thing. We're just gonna write our thing through differently. This was supposed to be an x right here. So basically, this piece is represented by f of x. this guy is acting as like the x minus k portion. And I need to figure out what q of x is and what the remainder is. So, let's set up synthetic division. So what number goes in the box? 81. And my coefficients?
3, 4, 3 and 10, 0.
Right, we skipped over the x, we have to have a 0. Alright. Then go through the process. Alright, so what numbers will I get out? Okay. So let's just write it out. F of x can now be rewritten. So how would I express this 3, 1, negative 11, and positive 11? How do I express the polynomial that I have left over here? Yeah.
Mr. Rowe, please call the office. Mr. Rowe.
Okay, so I want to express this as a product plus my remainder. So this is what I would get out. But if I want to write it like they want us to with this whole part of it, I have my x minus k, which was like the x plus 1 piece. I have my quotient, which is this part that I just got out. This is q of x. So I'm just going to rewrite it, p multiplied to x plus 1. And then I'm adding just the number for my remainder, so not even the fraction, just the 4. So this is how they want you to express the answer with the words that they used. So basically, if you would multiply this right side out and add 4, you should get out the 3x to the 4th plus 4x to the 3rd, and blah, blah, blah. Right, so if you wanted to check your work, you could. But that seems kind of like being that to me, so I won't. Just trust me, right? Okay. So not too shabby. We'll be spending more time this week with synthetic division, basically. Cool. I graded your test. Except nobody's here to even like see their test.